What we're going to do now is we're going to take all the pieces that we've talked about in the last few lessons and put them together. So this is kind of where we've been leading to all the way along. I'm just going to use this sheet. I might go back and forth on this sheet a little bit, but it's because I want to do one part and then come back and do another part. All right, so let's just say we've got our sodium ion. So we're just going to draw our sodium ion. All right, it had one electron in its outer energy level in that valence shell. Remember we said that sometimes electrons will be lost or gained by atoms, and we had one single electron in that outermost energy level, and it can be pulled off if there's something that's closer that tends to gain electrons. So our little sodium here has a charge of +1. Now let's just say floating around in the same area we have a chlorine ion. All right, so chlorine's floating around. All right, and if we remember 1, 2, 3, 4, 5, 6, 7, if it tends to be around something that gives up electrons, it's going to scoop an electron from elsewhere. So this electron is the one that it found from somewhere else. And you don't have to do that in a different color. I'm just doing it so that we know the difference. And because it has one extra electron, it now has a charge of -1. So we talked about that last time. A couple things I just want to add in here. When we have positive ions, notice the positive ions are metal, right? And they are called, if you have a positive ions, they are called cations. And how I remember that is that little plus there, that little T sign looks like a positive sign. So a cation is a positive ion. So our metals form positive ions called cations. On this side here, we've got our nonmetal. So this is our nonmetal. And this guy forms an anion. And I just remember this because that's got a little N in there for negative. And this one is a negative ion. So if we form negative ions, I'll put a little arrow here so that later on you're not going, what the heck? Right? So the anions form, or the nonmetals form negative ions called anions, and the metals, atoms, form positive ions called cations. All right, so now we've got a metal and a nonmetal side by side. They have opposite charges. So remember we said that these things tend opposites attract. So what's going to happen here is there's going to be an electrical attraction between these two ions. Right? They're not going to physically ever touch each other, but they're just going to stay really, really closely associated with each other because they have opposite charges. Now, when this happens, we form something that's called a compound. So a compound, leave yourself a little bit of room in here. A compound is anything where we have two or more different elements chemically bonded. I'm going to put together here because it just sounds weird saying they're bonded. All right, so they're chemically bonded together. They don't actually touch each other. There is a chemical attraction between the two of them. Now, because we've got two ions that are chemically bonded together with this thing, this is called an ionic bond. Because we've got these two ions together, we would say that this particular thing that we formed here is going to be an ionic compound. So an ionic compound is a compound that forms between two ions. So an ionic compound is a compound made up of ions. All right, so we have a positive and negative ion that are chemically attracted to each other in this ionic bond here. All right, let's try another one, and then we're going to come back to this guy. So let's try another one. Let's just say we have our sodium bombing around there again on its own. All right, loses an electron because it doesn't know how to take care of that one, can't keep it attracted to it. Okay, so that's bombing around out there. And then let's just say we've got an oxygen. Oh, I forgot to say this one thing up here. Okay, I'm going to go back up to this diagram when I'm finished with this little diagram here, okay? So we've got our oxygen 1, 2, 3, 4, 5, 6, and because it has 2 unbonded electrons there, it's going to, or 2 unpaired, it's going to scoop 2 electrons from somewhere. Okay, take a break from this. We're going to go up here because I need to say something else. So if we look at this compound that's formed, all right, we know this is +1 and this is -1, but the whole entire thing, I wish I had a pencil or something, this whole entire compound together, if we look at the overall charge of it, +1 and -1, the overall charge is 0. All right, they've balanced each other out. They've neutralized each other. So that's going to be important for this next part here. So when we form a compound, we're going to form a compound that has an overall charge of 0. So we have 1 sodium and 1 chlorine. They're chemically attracted to each other in an ionic bond, and we form an ionic compound. So here we have our sodium that has a charge of +1, and we have our oxygen here that's got 2 negative electrons from somewhere. So this guy's going to have a charge of -2. Now, if this formed a compound at this point right here with these two, of course they're chemically attracted to each other. So if this forms a compound right now, this would be -2, this would be +1, and the overall charge of this would end up being -1. Well, that can't happen. It has to be neutrally charged, all right? So in order for a compound to form, we have to end up with a neutral charge up here. So, what can we do? And we can only use sodium, and we can only use oxygen. These are the only 2 things that we're going to be making a compound with. Well, what if there was another sodium floating close by? Alrighty, so we've got another sodium floating close by, charge of +1. Alright, perfect. This guy can also be attracted here to this. And if you look at this now, this whole compound, right, the overall charge, if we've got -2 here and we have 2 +1s here, our overall charge is going to be 0. Alrighty, we're going to do one more and then we're going to come back to our first diagram. So now let's pretend we have something like calcium. Right, so calcium's buzzing around. Calcium had 2 electrons in its outer energy level, but it lost those 2. Right, so now it's an ion, and if it lost 2 negative, it's become 2 times more, two more positive, so it's become +2. Lost 2 negatives, so now it's become +2. And let's just say we'll go back to our chlorine. We've got some chlorine buzzing around, all right? So chlorine, 1, 2, 3, 4, 5, 6, 7, and that unpaired electron, it's managed to scoop an electron from somewhere else. And its overall charge now is going to be -1. So if we did a compound with these 2 here, right, we have a +2 here and a -1 here. If it was just these 2 that were in the compound, well, our overall charge of our compound would be +1. These 2 guys wouldn't neutralize each other enough. So it's got to be neutral. The rule is that the overall charge of the compound has to be 0. It's got to have a neutral charge. So happily, along comes another chlorine, just zipping around, doing its thing, with 1 extra electron on it, which gives it the charge of -1. Oh, look at this. We can have another attraction in here. Okay, so the overall charge on this one now is going to be 0. So the overall charge is 0. Because we have a charge of +2 here on this guy, because he's lost 2 electrons. We've got a charge of -2 between these 2, because each of these guys got 1 electron from somewhere. Alrighty, so now we have an electrical bond between these 2, a nice ionic bond between these 2. Alrighty, now that's a heck of a lot of drawing in order to try to do some chemistry, right? And who the heck wants to do all this drawing all the time? You're trying to do, big long chemical reactions, and you've got all these little drawings and little arrows and all sorts of stuff. So let's make life easy, right? Humans like to do things the easy way. So rather than drawing this thing out all the way, why don't we use the chemical symbols for it? So in this particular case here, we've got sodium and we've got chlorine. So let's just write this down easily, because we already know that if we have sodium and chlorine together, we know that sodium has lost an electron. We know that chlorine has found an electron, like we've learned that already. So we don't need to draw this out all the time. So let's put in the chemical formula. So we're going to use the chemical symbols still again. We're going to write this down as Na. All right, symbol for sodium, Na. Now, in this compound, how many sodiums do we have? Well, we only have one, right? If I'm looking at this compound here, I see one sodium and I see one chlorine. So I'm going to tell that in my formula that I have one sodium here. Okay, so this is telling me, this number when it's at the bottom here tells you how many atoms you have of each element. All right, and then beside it, we have our chlorine. Alrighty, and again, in this compound, we only have one. Now, we're going to take a lesson from the math people, because isn't that kind of silly that we're going to write one there and one there when clearly we have one and one, right? Why do we need to write the ones in there? So we don't need to write the ones in there. I just put them in there so that we know that that's the rule. This is going to tell you the number of atoms that are in that compound. Okay, let's put a little note here. Let's put number of atoms. Okay, so if you're looking at the formula, the little number at the bottom, the little subscript, tells you the number of atoms. So let's rewrite this, all right, a lot simpler, because why are we messing it up, putting little ones down there when, duh, obviously there's a one there, okay? So we were going to rewrite this properly as NaCl. All right, so there's our proper chemical formula for our compound that forms between sodium and chlorine. And this tells us that if we want to make this compound with the sodium and chlorine, we need one sodium and we need one chlorine. Now, next thing we're going to do is we're going to say, well, you know what, sometimes I want to say the words for this, like what this whole compound is. So this whole compound, we're going to do the naming of this now. So it's really, really easy. For all these things, the metal goes first and the non-metal goes second. That's just how the rule goes. And it's kind of nice because it follows how the periodic table, how the metals are on the left-hand side and the non-metals are on the right-hand side, so they go together. So we're going to take the metal name, which is going, I'll do this in another color since I'm squished here. So we're going to take the metal name first, which is going to be sodium. So sodium is our first element, and then we're going to take our second element, but we're going to change the ending to IDE. So this is now going to be sodium chloride. So that's the name of our element. So there's your salt that you put on your French fries is really actually sodium chloride. It's made up of one sodium and one chlorine. Right, again, so sodium chloride, NaCl, is sodium chloride made up of one sodium and one chlorine, and it's an ionic compound because it forms between two ions. Sodium loses an electron, becomes positively charged. Chlorine gains an electron, becomes negatively charged. Opposites attract. We got metal and non-metal. We have positive and negative, one and one, so we end up with an ionic compound. So, same thing down here. Let's go down here and take a look at this. Rather than drawing out this great big thing all the time, let's make life easy and just put down the chemical formula. So in this particular case here, if we're looking at this compound, we have sodium. Metal always goes first, so we have sodium. Now, in this case here, how many sodiums do we have? Our rule up here says we show our number of atoms by putting a subscript. So over here we have 1, 2, so we're going to put a little 2 down there. Right? Now we have to leave the 2 in because it's more than 1. So just like in math, we can erase the ones that are at the bottom. Well, not erase them, but we don't have to write them down. So in this particular case, we have to leave the 2 down there because that's telling us we have 2 sodiums in this compound. But for our oxygen, we can just put oxygen and just understand that there is a 1 there. We don't need to write it in, but that's what it is. And again, we're going to use its chemical name. So I'll do this in purple this time because it's kind of squished. So our chemical name is going to be sodium. And our last name is going to end in IDE, but for oxygen, we're going to change it a little bit more. So it's going to be ox. Right? We're going to take the Y-G-E-N and we're going to call this sodium oxide. All right, so there's your sodium oxide. All right, our next guy here, and I believe sodium oxide is used like in laundry detergents and stuff. So our last one here, our last example here, we're going to take our calcium and our chlorines, and let's write this one out as its chemical formula. So we've got our calcium, and how many in our compound? We've got 1. So understood to be a 1 there. And then with our chlorines, we've got Cl, and we've got 2 of them. All right, so that's how simple it is to go from our ions to our, oops, I forgot to put the name there, from our ions to our chemical formula. And now we'll do our name. So our calcium and our chloride. All right. So that's how simple it is. I'm going to do a couple more examples. I've got some cutouts that if you were in class you would probably be using, and you're going to do a lot of this in grade 10. So if you can remember this right now, you're going to be way ahead in grade 10. So let's take a peek here. Let's say I've got some potassium here, and I've got a I'll put a sulfur. Okay, so I've got potassium and sulfur. So I've got my potassium and I've got my sulfur here. Alrighty. My sulfur has a charge of -2. My potassium has a charge of +1. They're chemically or they're ionically bonded to each other. There's an electrical bond there, but they're not actually touching. But this compound right now is not charged overall neutral. So what I'm going to have to do is, if there's going to be another potassium that's floating around, we're going to have him in there too. So the formula for this is going to be, right, K, and we've got 2 of them, 2, and then 1 sulfur, K2S. And this is going to be potassium, and the ending here is going to be sulfide. Now sometimes you're going to see the American spelling for sulfide, and that will be Sulfide. Both of them are okay. This is the Canadian way to spell it. Alright, so that's going to be one of those ones. Now I'm going to do one more, and then you're going to be able to go and work on your worksheet. Okay, so this one here, I'll flip the page over. This one here, we've got a phosphorus, and let's just say we've got some lithium floating around. So there's a lithium. So this one's got a charge of -3. This guy's got a charge of +1. So if we were to make a compound out of this, our overall charge would not be 0. It would only be -2 because we've got a charge here of -3. So we're going to need 1 and 2 more lithiums. And remember, these guys are electrically attracted to each other. This is a very strong bond. So now we're going to do our chemical formula. So we know we've got lithium. Metal always goes first. So we've got Li, and because we have 1, 2, 3, where it's going to be Li3. All right, and we've got 1 phosphorus, so it's going to be just the 1. And the name of this, again, metal name first, this is going to be lithium. And his last name is going to be phosphide. Now, if you're ever unsure about the endings, okay, if you were to say to yourself phosphoride, it just doesn't roll off the tongue very easily, right? It's not, or phosphoricide or something like that, all right? It just doesn't, it's hard to say. But if you say phosphide, it's easy to say. Same as sulfide is easier to say than sulfuride or oxygenide. All right, so when you're trying to, if you can't remember the names of it, just try to see how easily it you can say it, and that'll give you an indication if you've got the name or not right for the last name. Alrighty, so there's this. You can work on your worksheet, and that's it for today.